It started with a warning, then silence. Your classical optimization pipeline didn't get murdered. It bled out from combinatoric wounds while everyone argued about budget. You're asking me to manage qubits? I barely trust my VM agents to reboot on schedule. Here's the truth. Optimization is everywhere. Classical stalls at the exact moment costs start leaking, and Azure's hybrid quantum tools already live in your tenant. We're dissecting one algorithm, QAOA, one Azure demo pattern, and the one part of quantum that breaks everyone's brain. Bits were clean, one. Now they're maybe. Fantastic. Let's autopsy before the coffee oxidizes. The autopsy begins. Why quantum exists. Forensic cause of death. The corpse on the table is an enterprise optimization problem. The tag reads, NP hard complications. Time of death logged right when the solution space exploded. Classical hardware hit the physics wall. Frequency scaling slowed. Core counts got you only so far, and GPUs said, I accelerate arithmetic, not your exponential grief. Upon closer examination, the charts show what killed it. The number of possible configurations grew like a tumor. Routing, scheduling, portfolio balancing, each variable doubled the search. Heuristics begged for mercy. Local minima formed a neat little graveyard. The evidence suggests classical didn't fail everywhere. It failed exactly where you needed global structure under pressure. Enter qubits. Not magic, just different physics. A bit is or one. A qubit sits in a superposition, which is a fancy way of saying it can explore many maybes at once, and you only pay the measurement bill at the end. Think of superposition like opening every door a crack, instead of marching through hallways one at a time. You still commit to one door, but you sampled the draft from all of them. Entanglement is where variables whisper behind your back. Classically, coordinating constraints across a graph requires message passing, caches, and time. Entanglement creates correlations that travel with the state. No email sent, no tickets filed. Constraints become knitted into the system. That's not mysticism, it's how the math encodes relationships. Interference is the sharp instrument. Good paths get their probability amplitudes amplified. Bad paths cancel like two angry auditors negating each other's report. It's code review with face kicks. Your circuit encourages feasibility and suppresses nonsense. In other words, the machine doesn't brute force. It steers. Now, reality check. Today's quantum hardware is small and noisy. Fault tolerance isn't ready to drive the hearse. This is why Azure's approach is hybrid first. You run a parameterized quantum circuit, then let a classical optimizer adjust the knobs. Rinse, repeat. Quantum proposes, classical disposes. You don't solve on the chip. You shape a probability landscape and harvest better answers earlier. Azure Quantum makes this painfully practical. You get a workspace, simulators for development, and selective access to QPUs for production sampling. Tooling spans Q+ for circuit definitions and Python for orchestration. You submit hybrid jobs, watch iterations, and only pay for what actually runs. No Mystique surcharge. Anti-hype clause. No, this won't crack RSA tomorrow. If someone says it will, they moonlight selling crypto on TikTok. We are not here for prophecy. We're here for reductions in congestion, overtime, and risk. Places where wasted compute becomes wasted cash. Business translation. Logistics, finance, energy, workforce planning, the same unsolved puzzles wearing different uniforms. When constraints fight, classical gets tired. Hybrid methods don't guarantee a miracle. They tilt the odds and cut time to decision. Everything clicked when the trial runs showed consistent, earlier improvements on problems that previously demanded heroics. There's exactly one part that breaks everyone's brain. These circuits aren't deterministic programs, they're statistical experiments. You don't read the answer, you read a histogram and translate it back to the thing you're optimizing. Get over that and the rest is plumbing. So how does QAOA slice this case without summoning demons? The next cut reveals the mechanism. Cost, Hamiltonians, mixes, angles, and a loop that refuses to die until the landscape yields. The core pattern, hybrid QAOA on Azure, mechanism of death plus reconstruction. Cause of death was not a single wound. It was system collapse under combinatorics. QAOA is the reconstruction, triage first, surgery second. Here's the pattern that keeps the patient alive long enough to talk. Why hybrid? Because the quantum device is a talented but exhausted intern, smart instincts, shaky hands. The classical host is the veteran attending, steady, skeptical, slow under pressure. Put them alone and they fail differently. Put them together and you get fast intuition guided by measured correction. The quantum side explores many maybes at once. The classical side decides which maybes deserve another look. What is QAOA in clinical terms? You build two operators, a cost Hamiltonian that punishes the things you hate, conflicts, overages, violations, and a mixer that lets the state move around the search space without getting stuck in a local morgue drawer. You stack these in layers, p times. Each layer has angles, call them beta and gamma, that determine how long you press on penalties and how aggressively you stir the state. Those angles are your knobs. Loop mechanics are the autopsy rhythm. Plan angles, execute the circuit for a batch of shots, measure bit strings, score them with your cost function, and feed that score into a classical optimizer that proposes the next angles. Repeat until the objective stops bleeding. The quantum hardware never declares a verdict. It coughs up distributions. The classical side reads the histogram and says, these bit strings look promising. Again. Problem classes fit neatly. Max cut models, conflict-heavy graphs, think networks, clustering, portfolio hedging across correlated assets. Scheduling becomes binary assignment with penalties for overlap and shortages. Routing turns into edge decisions with capacity guards. If your constraints argue with each other, QAOA enjoys the drama. Azure's Workspace is the sterile room. You define a target, simulator for rehearsal, QPU for sampling. You submit a hybrid job, and Azure coordinates the dance. Classical host sits in Python, quantum kernels live in qpl or the Azure Quantum SDK, and the service keeps evidence, iteration metrics, histograms, parameter traces. You pay only for the compute you actually cut into, shots, iterations, wall time. No retainer for a corpse that never arrives. Tooling is blunt and sharp where it should be. QAOA expresses the circuit cleanly. Cost and mixer blocks assembled with surgical clarity. Python orchestrates the loop. Choose Kobila or Nelder-Mead when you need stable steps. Jump to SPSA when noise turns your gradients into gossip. Azure functions, schedules runs, retrieves failures with exponential backoff, and drops every artifact into storage, the evidence tray, while Azure Monitor watches vitals, cost decline, iteration time, back-end status. Here's the mini-rant. DevOps for physics means fewer Jira tickets about flaky cron jobs and more about phase errors and back-end queues. Don't pretend it's magic. This is CI show CD with a probability distribution. If your logging is sloppy, your story will lie to you. Common mistakes are predictable. Expecting speedups on toy graphs where any greedy heuristic wins. Waste of gloves. Ignoring noise and cranking up layers P until the state decoheres into mush. Measuring too early or too often, collapsing the state before interference does the heavy lifting. Treating quantum like a mascot instead of a tool, putting it everywhere instead of at the choke points. The counterintuitive part. Fewer, cleaner layers often beat deeper stacks on today's hardware. Shallow circuits, well-tuned angles, and enough shots to trust the histogram. Warm start angles from similar instances. Yesterday's schedule seeds, today's run. Transfer learning is not a buzzword here. It's time you don't want to spend resuturing the same wound. In practice, the workflow is short and cruel. Encode the problem into a cost function. Build QAOA layers at a modest depth. Choose an optimizer that won't panic. Run on a fast simulator to stabilize. Then sample a real device briefly to anchor the distribution in the noise you'll actually face. The hybrid loop does the rest, iterating until improvement plateaus, at which point you stop, not because it's perfect, but because the bleeding has slowed and the patient can be discharged with follow-up. Case file A, the logistics network that collapsed. Max cut. The tag on the first body reads, Regional Logistics Network, Chronic Congestion, Escalating Latency, cause of collapse, conflict-heavy roots strangling each other at shared hubs. Think of a graph where every overloaded edge is a bruise. Some are fresh, some are deep. All of them hurt throughput. Here's what the evidence shows. When trucks, lanes, and hub windows conflict, classical heuristics play whack-a-mole. Fix one corridor and another bursts. The configuration space multiplies like an untreated infection. Every new constraint doubles the fever. Local search finds a patch, then dies in the next valley. Max cut is the right autopsy tool here. Model the network as a graph. Nodes are hubs, edges are roots, and the weight on each edge reflects pain, latency, cost, variability, SLA penalties. The goal: partition the nodes into two groups to maximize the total weight of edges crossing the cut. In English, put conflicting hubs on opposite sides so high-pain roots get separated and traffic stops piling up on the same side of the skeleton. Encoding it is clinical. The cost Hamiltonian penalizes edges that don't cross the cut by subtracting their weights when endpoints land on the same side. It rewards edges that do cross. The mixer lets assignments flip without locking into dead tissue. Choose a modest depth P. 2 or 3 layers on today's hardware is usually the safe dose. Then give Cobila the stethoscope. It proposes angle updates based on the observed cost, nudging without drama. Procedure in Azure. Define the graph, build the QAOA circuit in qubits, set angles as parameters. Orchestrate in Python. Submit to the Azure Quantum Workspace. Start on a simulator, fast, sterile, repeatable. Run batches of shots. Pull the bitstring histogram, compute cut values for top candidates. When the distribution stabilizes, switch to a QPU for limited sampling. Enough to anchor expectations in real noise, not enough to torch your budget. Every iteration, lock the angles, the cost, and the top bit strings to storage. The evidence tray never lies. Interpretation matters. You're not hunting the single best bit string like a hero cop. You're looking at frequency. If the same partition keeps surfacing in the top 5% of samples, that's your lead. Translate bit strings back to hub groups, evaluate the cut size, and then verify operationally. Simulate flows with that partition, measure Q depths and root competition. The machine tells you these partitions look promising. Your domain model confirms they actually reduce bruising. KPIs read like vitals. A 15 to 30% reduction in measured congestion on high-weight corridors within the simulation window. A drop in edge conflict density, fewer overloaded pairs sitting on the same side. Faster stabilization of root partitions across planning cycles, which translates to fewer firefights for dispatch. Time to decision falls because the hybrid loop prunes the search without self-delusion. Automation is straightforward. An Azure function wakes on a scheduling trigger, ingests last week's telemetry to refresh edge weights, kicks off the hybrid job, and waits with exponential backoff. Results land in blob storage. A logic app posts the clinical summary to teams, top partitions, expected congestion delta, and a confidence score derived from histogram concentration. Azure Monitor watches for cost anomalies and failed shots. It pings you when the backend coughs. Pitfalls are exactly where you'd expect the body to tear. Too few layers and you get toy behavior. Cute but useless. Too many layers and the state decoheres into soup. Pick the wrong backend and you're measuring noise, not structure. And yes, reverse bitstring mapping horror. If your node ordering is off between QAOA and Python, you'll prescribe the wrong surgery to the wrong patient. Tag every artifact with the graph hash and the node index map, or enjoy the malpractice suit. The punchline: classical didn't die. It exhausted itself trying to brute force a political argument between edges. Hybrid QAOA gives you a biased coin that lands on better partitions more often, faster. That's enough to cut hemorrhaging without pretending you found perfection. Case File B, the workforce schedule that never survived. QAOA scheduling. Second body, a 500-person healthcare schedule. It didn't just expire. It was beaten to death by compliance rules and wishful thinking. Symptoms: shift imbalance, overtime swelling, compliance bruises from maximum hours violations, and resource inflammation every time a flu wave arrives. Under classical care, integer programming groans. Heuristics produce brittle rosters, and manual overrides pile up until the plan collapses. The search space is a landfill. Every employee, every shift, every constraint multiplies the mess. Local optima lure you into neat-looking schedules that fail the second a nurse calls out. We codify the schedule as binary variables. xi s equals 1 if person I takes shift s. Hard constraints become high penalty terms in the cost. Coverage minima, maximum hours per week, minimum rest between shifts, skill mix requirements, budget caps. Soft preferences sit lower in the penalty stack. Weekend fairness, personal requests. The cost, Hamiltonian, aggregates those penalties so violations sting more than mild discomfort. The mixer encourages exploration without tearing apart feasible islands. Hybrid QAOA fits because feasibility isn't binary here, it's layered. You want the circuit to steer toward feasible zones and let the classical optimizer sand down the rough edges. Kobila earns its coroner badge again. It crawls the angle space, ignoring the squeals of noisy gradients, looking for steady cost declines. Nelda Mead is an alternative when Kobila stalls. SPSA is your backup when measurement noise turns the surface into static. Loop protocol is pragmatic. Validate feasibility first with a lightweight classical pre-check. If the instance is impossible, don't waste shots. Choose a conservative depth P, seed angles from a similar historical schedule. Transfer learning that actually transfers. Run on a simulator to stabilize, then sample a QPU enough to confront noise reality. Aggregate histograms, extract the top bit strings, and translate them back into people on shifts. Cleanup is non-negotiable. Reapply hard constraints to sanitize candidate schedules. If a bit string violates a hard rule, fix it minimally or discard it. Sanity check coverage counts per hour block. Check overtime exposure. Compute compliance risk. Never trust a single winner. Consensus across the top cluster is the signal. If multiple high-probability bit strings converge on similar rosters, you've got a robust plan. KPIs read like a TOC screen. Overtime drops 10 to 25% as coverage spreads, without drowning the same staff. Coverage compliance improves. Fewer red blocks on the dashboard, fewer escalations. Time to schedule falls sharply. Planners regain hours per cycle instead of negotiating with spreadsheets at midnight. And the real tell, when a constraint shifts, budget cut, staffing dip, the hybrid loop reconverges faster than the classical incumbent, bleeding less in the transition. Guardrails keep the patient from coding on the table. Tune penalty weights so hard, rules are truly hard. Don't let a pretty preference outweigh legal rest. Validate feasibility upfront so the optimizer isn't chasing ghosts. Sanity check top solutions against real-world edge cases, double licensed roles, floating staff, union constraints, and log everything: angles, costs, histograms, constraint violations, so the post-op report explains why a roster was chosen. The micro rant: scheduling is human Tetris with legal landmines. You won't get applause for elegance, only rage when it fails. QAOA cheats better because it searches broadly, then lets the classical side make sober decisions. The result isn't beautiful, it's resilient. In healthcare, that's the only metric that keeps the pulse. Architecture breakdown. Hybrid quantum in Azure. Sterile room setup. Every morgue needs a sterile room. In Azure, the sterile room is a quantum workspace tied to identities you actually control. No sticky notes with secrets, no interns with owner rights. The body arrives zipped. You unzip only what you need. Identity and security first. Submission uses managed identity so the host code never touches keys. RBAC keeps the blast radius sane. Reader for observers. Contributor for operators. Workspace, admin for exactly one poor soul who signs for the bodies. Storage accounts are hardened. Private endpoints, encryption at rest, immutable blobs for evidence. Diagnostic logs flow to log analytics, every incision time-stamped, every parameter tagged. Automation is the quiet assistant. Azure Functions triggers the hybrid job, on schedule, on file drop, or on command. Logic Apps orchestrates multi-step procedures, refresh weights, submit job, poll status with exponential backoff, archive artifacts, notify outcomes. GitHub Actions packages Q+ and Python into a deployable unit, stamps versions, and refuses to ship unlinted circuits. If your CI/CD is sloppy, your AUTOPSY notes will contradict themselves. Execution is simple on paper, cruel in reality. The classical host orchestrates in Python, builds the cost, picks the optimizer, manages angles. The quantum backend, simulator for rehearsal, QPU for sampling, executes the parameterized circuit. The message back isn't a sentence, it's a histogram. Think vitals chart, not confession. The host scores the samples, updates angles, and repeats until the numbers stop improving or your cost cap yanks the plug. Observability separates professionals from hobbyists. Track objective value per iteration. If it plateaus, stop pretending. Log angles, shot counts, backend IDs, store histograms, not just best strings. Post-op audits need distributions, not anecdotes. Azure Monitor watches the vitals, iteration durations, backend queue times, job failure rates, spend per run. Alert on cost anomalies before finance alerts on you. Cost posture, simulators for development, targeted QPU shots in production. You don't need to drown in quantum at boir shot. You need enough to anchor reality. A dry joke about cheaper than Cosmos lands once, but the principle stands. Pay for evidence, not spectacle. Pre-provision the tools. Don't perform a live setup while the cadaver warms. Workspace, storage, key vault for external secrets you can't avoid. Function app, log analytics, ready before the first incision. Templates exist, use them. Tag everything with a case ID and a retention policy. In this environment, nothing is accidental, especially the messes. Here's the flow without romance. Function ingests new instance data. It hashes the graph or schedule, checks storage for prior angles, warm start if found. It submits the hybrid job to the workspace with cost caps and iteration limits. It polls safely, handling transient backend coughs. When results arrive, it writes the angles, histograms, scores, and decoded candidates to immutable storage. Logic App posts the clinical summary to teams with links to the evidence. If a step fails, an alert fires with enough context to fix it without guessing. The takeaway: architecture is the biohazard protocol. It doesn't find answers. It keeps you from poisoning the lab while you look. Motive: why Microsoft wants you on quantum early. Let's talk motive. Why does Microsoft want you elbow deep in quantum before the machines stop shaking? Because the stack is already theirs and yours. Python for orchestration, Qpl for circuits, Azure for identity, storage, and monitoring. It's the same DevOps muscle with unfamiliar math. They're not asking you to change religions. They're asking you to add a ritual. Future-proofing is boring and correct. Hardware will scale later. Your scripts, pipelines, and governance won't write themselves the night fault tolerance shows up. If you build the hybrid muscle now, parameter plumbing, histogram literacy, cost governance, you won't be learning to intubate during a code blue. The day larger devices land, your loop simply deepens. No migration panic, no what do we log scramble. Business case is not theology, it's margins. Logistics, energy, finance, scheduling, every % of improvement compounds. Early movers don't own magic, they own process. Hybrid jobs right now tilt outcomes earlier. That means fewer firefights, fewer replans, less executive time spent pretending spreadsheets are strategy. If your competitor reduces time to decision by even 30%, they make fewer bad calls under stress. That's motive anyone understands. Practicality matters. You don't need fault tolerance to run max cut on a simulator, warm start from last week, and take a few QPU shots to calibrate. The ROI isn't quantum supremacy. It's we stopped burning hours chasing dead ends. The win shows up as stabilized KPIs, not as a press release. The unified stack is the quiet part said out loud. Microsoft wants the path from new optimization instance arrives to hybrid job submitted, monitored, and archived to feel like any Azure workflow. Once your team treats QAOA as just another job type, the rest is incremental. New circuits are packages, new backends are targets. The scaffolding doesn't care, and there's a defensive motive. If you learn this within Azure, you won't wander off to bespoke platforms that fracture your telemetry and identity. Centralized logs, unified cost controls, familiar RBAC, these are the handcuffs you willingly wear because they save you from yourself. Still, the cynical read is also true. They want you invested early so you don't switch later. Fine. Use that gravity. Extract budget for hybrid pilots under innovation while quietly building durable plumbing. The day the hardware stabilizes, you won't be shopping. You'll be scaling. In the end, early adoption isn't romance. It's leverage. Best practices: security, reliability, interpretability, clinical protocols. Start like a professional, not a suspect. Security, least privilege everywhere. Use managed identity for submission, key vault for anything you can't avoid, private endpoints on storage, and immutable blobs for evidence retention. RBAC is a scalpel, reader for auditors, contributor for operators, one Workspace admin who signs the toe tags. Audit parameters, log every angle vector, shot count, backend ID, malpractice, lives in missing context. Reliability, simulators for debugging, always. Poll jobs with exponential back-off, transient backend coughs aren't omens. Validate optimizer steps. If the objective spikes or returns, NAN, roll back and reduce step size. Version circuits and cost functions. Store run manifests with hashes so you can reproduce the scene without memory theater. Performance. Keep QAOA depth lean. Shallow circuits survive real noise. Reuse simulators across runs. Cache classical precomputations. Warm start angles from similar cases. Seed randomness for repeatability. Spend shots where it matters. Batches big enough to trust the histogram, not vanity sampling. Interpretability, visualize the full distribution, not just the winner. Translate bit strings to domain terms, hubs and shifts, not S and ones. Reapply hard constraints as a final sanitizer. Never trust a single sample. Look for consensus across the top cluster. If your histogram is flat, you didn't learn anything. Either the encoding is bad or the depth is wrong. Governance, tag jobs with case IDs, owner, data sensitivity, cap cost per run, enforce retention windows, and lock evidence. In this environment, nothing is accidental, especially the audit trail. The gotcha that ruins most quantum jobs, statistical cause of death. Here's the body on the floor, treating circuits like deterministic programs. They aren't, they're statistical experiments. The fix is boring and effective. Enough shots to estimate distributions, correct measurement timing, and aggregation over anecdotes. If a single bit string makes you euphoric, sit down. You're reading noise. Parameter sensitivity is the second bullet. Bad initial angles waste iterations. Borrow angles from solved siblings, sweep coarse grids before fine search, and throttle optimizers that sprint into chaos. Checklist before scalpel. Backend correct, shots sufficient, constraints validated, interpretation mapped, parameters logged, snapshots stored. If results look weird, congratulations, the math is fine. Your story isn't. Key takeaway. Quantum doesn't replace classical, it pressures it into better answers through a disciplined hybrid loop that stops the bleeding faster. Start one hybrid job, encode a max cut or schedule instance, stabilize on a simulator, move orchestration into a function, then sample a real QPU just enough to anchor reality. Subscribe and cue the next episode where we dissect parameter warm starts and histogram diagnostics, the lab work that separates useful findings from forensic fanfiction.